All right, I just want to ask if everyone is okay with the test and written portion of the test. I know last night Adriana found an issue with the quiz, so I rushed and made sure everyone can upload the quiz, so thank you for that.
There was one question. Josh was asking me yesterday, there's two, hold on, let me see.
On the quiz?
On the test. He said there was, on question 3, there's two densities. Or no, question 2, there's two delta H fusions for water.
2 delta H fusions of water.
Yeah, there's supposed to be two. Like
What question is that? What type of?
Number 2.
Is it the quiz or the exam?
The exam. I can show you. I don't know if it's right.
Is it like the is it this? Oh, they're close enough.
Okay, so
Yeah,
whichever.
6.09, 6.01.
Okay.
It's fine. I think that's my error. I think
No,
one
that's
or the
fine. I
other.
just didn't want to do it wrong. Thank you. I didn't want to do it
Yeah,
wrong.
thank you, Ariana. Yeah, Ariana.
Adriana. Thank you, Ariana.
Isn't that a Disney character? Ariana? No? Adriana? Sorry.
Ariel, I think.
I thought that was a Disney. It is. It is a Disney character. It is.
Maybe it's a new one. I don't know.
You can use any delta H. Let me tell this for the people that are watching. No one watches these, by the way, but use. Oh, you do? All right, one person. Use delta H fusion, anyone for. What question is that? Question 2 on the written exam. I probably wrote it and was rushed, and I'm trying to make sure it goes well. All right, for those of you, written exam question 2, there's 2 delta fusions. They're pretty close. One is 6.09, one is 6.01. I think you should be able to get somewhere close to the reasonable right answer if you use either one. Okay? So Josh, I got your question. So use either delta H fusion.
Okay.
But it's close enough.
Okay.
6.09, 6.01.
Pick whichever you want.
Yeah, pick whichever one you want. We're grading the process. Okay? Process. Any other questions?
I have one more.
Right.
On the percent whole question, when it has the density of HCl, is that the density of HCl or the density of the HCl aqueous solution?
It's the density of the HCl aqueous solution.
Okay, thank you.
Density of HCl equals density of HCl solution. Anything else? That's the written exam.
Yeah.
Is okay uploading it? Whoever did it, I mean, you don't foresee any. No one uploaded it. Okay, that's fine. Yeah.
The scanner part isn't open on the test portion. Like for the quiz, you can scan your written answers, but for the test, it won't let you scan it. It will only let you upload a file.
Okay.
What is wrong with him?
I have to look into that. Okay. I think. Okay. I'll look into that when I get home. I mean, do you think you can upload it, or
Yeah, you can upload the file. It's just the scanner isn't open. That's all.
can you take a picture and
Yeah,
and scan it?
Canvas has like a scanner option. Like when you hit submit assignment, it says like you can upload a file,
Right.
text box, or you can scan it.
Right.
And like usually you can click the scanner option, and then it will scan the picture for you, and then upload
Really?
it right away.
Oh, that I didn't know.
I didn't
Yeah.
know that existed.
I think
I
it's an
usually
update
take a
that they
picture
just did.
Yeah.
I really struggle with Canvas. I go to their communities, and whatever their community, I even typed in something like You know those, what are they called? Community blogs,
Yeah.
bulletin boards,
Forums.
forums. Yeah.
I think it's easier to track all your assignments though with Canvas than one.
Really?
By due date, yeah.
Okay.
Except when your teacher doesn't put any due dates on anything, it just gives you a separate file for all your due dates.
I'm probably guilty of doing that. I don't know.
It's not you.
Yours is great.
So let me look into that file uploads situation and file uploads of scan. I know there's a thing where you click file uploads and you're supposed to restrict. You can restrict certain files because last semester somebody was scanning me some weird HESIC file format. It made no sense, and I couldn't grade it. And then I put restrictions. I only put DocX or JPG or TIFF. Let me look into that.
I'll show you what I'm talking about after class. I'll show you.
Right. If you can take a picture and we can read it, there's, me and my assistant. If we can read it, that's fine. We'll see. Yeah, just talk after class. File uploads of scan for quiz, right, or everything?
The test. Just the test.
For a test. All right, I'll look into that. Anything else? I don't think anyone did the multiple choice, right? No one? Okay, you'll do that tonight. Right, so any issues, just come see me. If there's any wrong answers, like you don't see the you don't see the right answer, I'll make the corrections after everyone has taken the exam. Now, that happens. I may have made a mistake, but I correct that afterwards. All right, so. All right, so the big thing is the test and also upload the quiz. Okay. And after that, today will be over, and then we'll have a normal, I'll resume housekeeping on Wednesday. I'm going to move on to chapter 13, okay, just for the sake of pushing forward. And so where we left off was something called rate expression. By the way, today is, what is today? The 15th. Okay, rate expression. So this is different than rate law. Okay, so different than rate law. Rate law is something I will ask you on your exam and on your next quiz. All right, but let me go over rate law. Let me go over rate expression. And then we'll focus on rate law. In fact, you'll actually have a lab, I think coming up lab, not this Friday, but next Friday, where we do a rate law. So it's a crazy, crazy lab. These labs are getting a little messy, you'll find. I think last Friday, Larissa told me. So it's going to be like that. Data is messy. Experiments are messy, and you're going to see that. You'll see that a lot in Chem 2. Right, so first, let me talk about rate expression. Right, so here we have an equation here. All right. So what happens as this reaction proceeds? What happens is that over time, remember, rate has something to do with time. Okay, how fast? How fast? Okay, this whole chapter 13 is dealing with how fast. Is it fast? Is it slow? How do you know? We put a number by it. The number will tell us how fast or slow it is. So over time, this CH4 is going to go down. All right, so I'm going to call this the concentration of CH4. And this bracket means big M, which equals moles over a liter. All right, moles over a liter. Okay, units, for those of you taking the multiple choice question of the exam later, units, moles over liter, molarity. Moles of solute over liters of solution, molarity. Moles of solute over kilogram of solvent, molality. So this is going to go down. Another thing that will go down is O2. Okay. And just as those go down, what's going to go up? Okay, we want to have a successful reaction, correct? We do chemistry to get reactions. And as reactants go down, these products should go up. Okay, CO2 should go up in the green concentration, and the H2O should also go up concentration over time. Okay, concentration on the y-axis. All right, so this rate expression sort of tracks that. So this is how we're going to do it. This is called delta, and the delta CH4 over delta T, that lowercase t is time. Okay, we're going to put a negative sign here because reactants go down. Okay, that delta is delta. This actually is calculus. Believe it or not, I'm teaching you calculus. Right? No? Rate of change over time is calculus, or a form of calculus. That's going to go down, and just as it goes down, we're going to put another minus sign here, and it's going to be 1 over 2 change in O2 concentration over time. Okay, why did I put minus? Because reactants go down. Okay, why did I put the 1/2? Because we have 2 moles. Okay, that's the rule for rate expression. Okay, it's 1 over. Okay, that has to equal the products. The products are going up. They're going up, so it's going to be a change in the concentration of CO2 over time equals, I'm running out of space here, equals positive 1/2 change in H2O over time. I'm running out of space here. So this is rate expression. You may see this in your MCAT or whatever future exams, so I'm just going to go over it, but I'm not really going to ask you a question on the exam. Why is this 1/2 and why is it positive? It's positive because it's a product. You know, products go up over time, and then it's 1/2 because there's 2 moles here. So again, this is called rate expression. And like I said before, you may see it in your future chemistry classes and your medical. So a lot of medical people take chemistry for pre-med and whatever. All right, let's do one problem, and then we will move on to rate law, which is the big one. All right, suppose H2 is being, okay, by the way, one last thing here. Before I move on, I want to highlight one thing here, and I want to highlight that these are gases. So this is an important point. If you have a gas, it can be one of 2 things. It could be concentration, which I've drawn here. Concentration, but it could also be pressure. So gases can be expressed in concentration or pressure P. Okay, pressure P. That only is for gases. Okay, and this is you know, what you can do if you want to express it in terms of pressure. R is the gas constant, T is temperature, lowercase t is time, P is pressure. Okay, change in pressure or change in concentration. for gases, pressure or concentration. Gases, pressure or concentrations. Gases, either say it to me in concentration, moles per liter, or say it to me in pressure, atmosphere, or whatever. Okay. Let's do this one problem here. So first of all, we're talking about rate expression. All right, so let's do the rate expression for this reaction. Okay, this is a reactant, pH 3. It's going to go down. So it's going to go down minus 1/4 change in concentration of pH 3 over delta lowercase t time. I could also do it in a pressure, but I'm only doing it in concentrations. Okay, minus. Okay, change in concentration over time. That has to equal to the change in concentration of P4 over time. And that has to equal to 1/6 change in concentration of H2 over time. This is a rate. Over time is a rate. How fast? Again, y minus 1/4 because of the 4 here. And y the 6, y 1/6 because of the 6 here. This problem tells us H2 is being formed at this rate. Okay, molar over seconds. Think of this as miles per hour. Miles per hour. But in chemistry, it's molar over second. And that is H2, so we're going to put that here. All right, so at what rate is P4 being formed? So the rate of change, the concentration of P4 over time, okay, is going to equal to, okay, let me explain it to you this way. If this is the rate of change, I'll call it X. It will be 1/6 x. This has no stoichiometry, it has no coefficient, so we'll call this x. And this is equal to 1/4 x. Okay. So this change in concentration I'll call x, but because of the balanced equation, 6 moles, it's increasing, but it's increasing 1/6. So the change in concentration of P4 over time is actually X. The change in concentration of H2 over time is 1/6 X. The change in concentration of pH 3 over time is minus 1/4 X. This is P4 over time is equal to X. H2 over time is 1/6 X. X minus 1/4 X for this, X for that, 1/6 X for this. Okay, because of the coefficients of the balanced chemical equation. All right, so here they tell us X is 0.078 molar over seconds. So H2 over time is going to be 0.078 big M over seconds times 1/6. And on my calculator, I'm getting an answer of 0.013, no. 0.078 divided by 6. 0.013. Okay, delta P, change in P4 over X, over time, is X, and they tell us X here is 0.078. And finally, this reactant, pH3 over time, decreases minus 1/4. So it's going to be minus 1/4 X, which is 0.078 M over seconds. And this is going to decrease. It will decrease at a rate of 0.05 to big M over seconds. Okay, minus 1/4 of X. Okay, that's a decrease, so you can even put a minus sign here if you like. It's a decrease. It's decreasing minus 1/4 X. They gave us the rate X here, 0.078 molar over seconds. Okay, H2, let me highlight this in black. And then finally, P4 over time. Let's highlight this in pink. So some exposure to rate expression, like I said before, you'll see this if you take future chemistry classes, possibly also in your MCAT or whatever next exam, big exams you take. All right, rate expression. Now I want to talk about rate law. This is something that definitely you will see on the exam. It's also important, and so we'll take some time and talk about it. Rate law. I think the way to really introduce this to us guys, is to just do a problem. So let's do a problem, and then you'll see what I'm kind of talking to you guys about. Okay. So a typical problem would be something like this. Okay, write the rate law for this reaction. That would be a problem you'll see on the exam, next exam. Problem you'll see on a quiz, next quiz. And the first thing when you see rate law, okay, make sure that they give you something like this. Okay, they give you a data table. Okay. So they need to give you something, I need to give you something, whoever needs to give you a table of different experiments. Okay? So here is the rate law here. It's going to be rate is equal to that lowercase rate constant, lowercase k. A lot of students, this is what makes Chem 2 hard, that lowercase k versus capital K. No, it's lowercase k, which is rate constant, times the concentration of the reactants, F2, raised to the order, so I'm just calling that A. You can call it B, C, X, Y, whatever. That's one reactant, times the concentration of the second reactant, because there's two reactants here, raised to the power of B, the order of that reactant. All right, it could be raised to the power of X, Y, Z, doesn't matter. So in this problem on the exam, quiz, okay, wherever, okay, we need to find K and its units. We need to find lowercase a exponent, and then we need to find exponent B. So A and B, these exponents are called the order of the reaction. Order of the, I will say order of the reactant. Order. Okay. And that order could be zero order decay. It could be first order decay. So this could be 0, 1. If it's 1, it's first order decay. And then it could also be 2 for second order decay. That's all I'm going to give you. That's all you'll see on the exam. Okay, so either 0, first, or second. Nothing more. Okay, nothing more. So that's what A and B could be. 0, 1, or 2. Those are the only three options. Okay. And the overall order of the reaction is A plus B. A plus B. Okay, whether F2 goes by 0 first or second order decay, whether ClO2 goes by 0 first or second order decay, the overall order of the whole combined reaction is A plus B. All right, so we got to find K, we got to find A, we got to find B. Here are the three conditions. Okay, so in experiment 1, they had this concentration. They kept the concentrations the same. No, they didn't. They concentration 0.1. Here the concentration is 0.01, and here is the rate. Okay, rate, molar over seconds. Kind of like miles per hour, but we're talking about it in terms of chemistry. How fast the reaction is going. Not miles per hour, but molarity over seconds. Experiment 2, they did 0.10. They kept that the same, but they increased this 4 times. And then in experiment 3, they doubled F2, but they kept this guy the same as experiment 1. So what are they doing? They're varying different things. Okay, they're varying things. Varying one, keeping the other constant. Varying the other, keeping this guy constant. Are you ready to do this thing here? Okay. By the way, just because you see a 2 here does not mean B is equal to 2. Okay. B does not automatically equal to 2. Okay. Okay. You can't just go and put 2 here for that. Okay, you have to solve for it. All right, so we're going to do step 1 here. We're going to compare 2 experiments. So I'm going to compare experiment 1 with experiment 2. Okay, experiment 1 and 2. Okay, so compare experiment 1 to experiment 2. Okay, so we'll have here experiment 1 over experiment 2. You can also do experiment 2 over experiment 1. You can do that. The math will come out the same. All right. All right, follow me. This is going to equal to rate 1 over rate 2 equals to rate constant K times F2 raised to the power of A times ClO2 raised to the power of B. All of that divided by rate 2 K F2 for experiment 2 rate 2 raised to the power of A, Cl2 rate 2 experiment 2 raised to the power of B. Can everyone see this? Sort of establishing a ratio. All right, step 2 here, let's put numbers in, plug it in, plug those numbers in. So we will plug numbers in. So rate 1, we have 1.2 times 10 to the minus 3. Rate 1, experiment 1. Okay, I'll put the units in. Whatever. Rate 2, everyone sees, is 4.8 times 10 to the minus 3. Equals rate constant K. We got to solve for that later. What's the concentration of F2 rate 1 experiment 1? Everyone agrees it's 0.10 raised to the power of A. What's ClO2b rate 1 experiment 1? It's 0.010 raised to the power of B. Okay. Rate 2K. What's F2 rate 2 experiment 2? It is 0.10 molar raised to the power of A. And then finally, if you guys follow my pen, ClO2 rate 2 experiment 2, 0.040 big M raised to the power of B. Okay, now let's cancel out units. Okay. M over seconds cancel. 1.2 times 10 to the minus 3 divided by 4.8 times 10 to the minus 3. Actually, on your calculator, I can do this in my head. It's 1/4. 1/4. All right, the little lowercase k cancels. Okay, we're going to find that at the end of the problem. 0.10 to the power of A, everyone see this? Cancels out with 0.10 to the power of A. All right. So 0.010 to the power of B divided by 0.040 to the power of B. Okay, everyone follow me here. 0.01 divided by 0.04 is 1/4. And I'm going to make that whole thing to the power of B. Everyone see that? I did. Instead of taking the exponent individually, I just put it the whole thing. Instead of here and here, I just pushed it up. Okay. And 0.01 divided by 0.04 is 1/4. Right. Believe it or not, this can be hard for some people. Can anyone solve for B here? Think. It's something that's so easy that you don't, because you're so bogged down in the thick of things. Right. B is equal to 1. Everyone see that? 1/4 to the power of 1 is just 1. 1/4 to the power of 1 is 1/4. Okay? So a lot of people, like I had a student my very first year teaching here, said, I don't understand this. It's like, how do you explain that? Everyone see this? Yeah, okay. Because it's like very in your face that you don't see it. It's not her, not that student, it's just, it's right here, you don't see it. Okay, 1/4 to the power of 1 is 1/4. Okay, 1/4 to the power of 1 is 1/4. All right, so what does that mean? Okay, it means that ClO2 reactant decays with first order kinetics. It means ClO2 reactant decays with, this is the abbreviation for with, decays with first order kinetics. Or first order kinetics. All right, we got B. Let's figure out exponent A. So step 3 is compare next set of experiments. Compare next 2 experiments. So which ones do you want to do? Let's go back up here. Okay, we compared 1 and 2 experiments. What should we compare next? I'm going to compare 1 and 3. Okay, so let's compare experiment 1 to experiment 3. Okay, so that means rate 1 over rate 3 equals K times the concentration of F2 to the power of A for rate 1, experiment 1, times ClO2 to the power of B, rate 1, experiment 1, divided by rate constant K for rate 3, experiment 3, times F2 to the power of A, rate 3, experiment 3, ClO2 to the power of B, rate 3, experiment 3. So let's plug in those numbers. Okay. All right, rate 1 is 1.2 times 10 to the minus 3. Rate 3 is, everyone see this with me, 2.4 times 10 to the minus 3. Equals lowercase k. What's F2 rate 1 experiment 1? F2 rate 1 experiment 1 is 0.10 molar raised to the power of A. What's CL2B rate 1 experiment 1? ClO2 rate 1 experiment 1 is 0.010. Raised to the power of B, but we know B is 1. Actually, we solved for that previously. Okay, all of that divided by now, let's do rate 3. Rate 3, experiment 3, F2 is 0.20, raised to the power of A. Times ClO2, rate 3, experiment 3, and our data table, that's 0.010. To the power of B, we solved for B, it's 1. Need a data table to solve this problem. let me see it. You need a data table to solve this problem. All right, are we okay, everyone? Uh, 0.010 m to the power of 1 cancels with that guy. Okay, your k's cancel. We got to work on them later. 1.2 times 10 to the minus 3 divided by 2.4 times 10 to the minus 3. By the way, these units cancel. That's 1/2 on our calculator. Okay, 0.1 divided by 0.2 is 1/2. Again, like before, I'm going to take those exponent a's, a and a, and then whoosh, I'm going to push them out. So that's 1/2 to the power of a. Notice I just pushed the exponent outer, made it outer. So what's a here? A is also 1. Okay. So what does that mean? It means that F2 reactant decays with first order kinetics. Decays with, that's our symbol for with, it decays with first order kinetics. Okay, we're not done. Okay, this is where a lot of students, I'm telling you now, this is where a lot of students just end it. Okay, but we're not done. This is a prime example of students missing points and not doing things to completeness. Okay, we want to do this to completeness and complete the problem. So this is what we have now. We have rate is equal to K times concentration of F2 raised to the power of 1. Okay, I'll just say raised to the power of 1 times ClO2 raised to the power of 1. Everyone see that? Right, our final step here, I'm going to call that step 4, is find lowercase k. Okay. Find k rate constant with the right units. Okay. This is where students really trip up on it. Okay, this is why you need the most keen attention here for this for this final step. Need everyone's keen focus here. How will we find K? Okay, use either experiment 1, 2, or 3. 1, experiment 2, or experiment 3 to solve for K. Okay, then don't forget the units. Units are going to be different each time. So which one do you guys want to use? Josh, Elena, Connor, 1, 2, or 3? Just pick a number, how you feel. 1? Okay, so we'll use experiment 1. Okay, you can use 2 and 3 also. You'll get the same answer. You'll get the same answer. All right, so rate, Connor, I'll just pick on you. What's the rate for experiment 1? 1.2 times 10 to the minus 3 m over s. Okay, equals K. What's the concentration of F2 for experiment 1? 0.10 raised to the power of 1. Remember, this is raised to the power of 1. Okay, raised to the power of 1 and raised to the power of 1. So 0.10 molar. And what about ClO2? Connor chose experiment 1, and ClO2 for experiment 1 is 0.010 molar. Raised to the power of 1. All right, this is another situation scenario that's ripe for math mistakes that could happen. So you see this 0.1 times 0.010. I'm going to move it down and isolate my k. This is just algebra. So 1.2 times 10 to the minus 3 big M. I'm going to keep moles over second. Okay, what's 0.1 times 0.01? 0.1 times 0.01 is 0.001 m squared. M squared. M times m is squared. Everyone see the m squared? Okay. Units. Because the k, lowercase k, has different units. So here, let me just underline it in pink. That's why we have m squared. Okay, and obviously 0.1 times 0.01 on my calculator is 0.001. All right, so this m here, big M, is going to cancel with one of the m's here, right? M leaving me with one m. So my final units here are going to be, this m cancels with that m, leaving me with an m in the denominator, a seconds in the denominator. So m in the denominator, seconds in the denominator. What's 1.2 times 10 to the minus 3 divided by 0.001? 1.2 times 10 to the minus 3 divided by 0.001. 1.2 is going to be my k. So here's my final answer. Let's put it here. Okay, the rate law is equal to rate equals to k. Okay, we just solved for k with the right units. We just solved for k with the right units. 1.2 divided by big M seconds times f2 raised to the power of 1 times ClO2 raised to the power of 1. And this is your final answer. The last 1 or 2 minutes or so, I'll ask Connor, all right, here's our final answer. Can you give me a number, experiment 1, 2, or 3? Anyone? 1, 2, or 3. Don't use 1 because you used 1 before. 2. All right, so I'm going to check my answer. So everyone should get this right on an exam. Check our answer. Okay, Connor says use experiment 2 conditions. All right, check our answer. So rate for experiment 2 is going to equal to 1.2 divided by big M over seconds times, what is F2 for experiment 2? F2 for experiment 2 is 0.1 big M. What is ClO2 for experiment 2? This is the one that Connor chose, 0.04. So I want you guys to know you can check your answer. Okay, raised to the 1 power. Okay, this is M. All right, M times M is M squared. So one of these m's will cancel with one of these m's, so we're left with m over second, right? One of these m's will cancel with one of these m's, leaving the m in the box. All right, here we go. It's winning time, I guess. All right, Connor, here we go. 0.1 times 0.04 times 1.2, 4.8 times 10 to the minus 3, m over seconds is rate for experiment 2. Yes. Got the right answer. So it matches. You can do the same thing for 3 as well. All right, so thank you for coming to class. Make sure you do the multiple choice. No one gave me any emails or text, so if there's an issue, let me know. If there's an error, I'll fix it at the end. Upload the written exam, and if you want to come, we'll talk about how we can upload it. Any issues, please come get to me. That should be your priority. Get finished that. And then Wednesday, we'll start our new set of lectures. All right, thank you. Have a good day. Yes, sir.
I've noticed a couple of times whenever you do the notes like this during class afterwards, you do it in black and white, and sometimes with the markers that you use, there'll be an entire section of something missing because
I'm trying to scan it in color.
Yeah.
I didn't do it on Friday. I couldn't get access to a color scanner.
Okay. That's all right.
But I'll scan it in color.
Okay.
Yeah. The secretary left. The person left. That was, yeah. But I'm going to try to get it in color. Okay, yes.